Alright, here we go with the last section of Chapter 5, 5.6. Here we're going to learn how to graph inequalities with two variables. So up until now, all of the inequalities that we've been graphing have just had a single variable x, and then the answer that you get is going to be plotted on a single number line. But here we're looking at multiple variables, so x and y, so your answer will be plotted on an xy coordinate system. In a similar way to when you have a solution to the equation of a line, it's a line in two dimensions on the xy axis. So the new key vocabulary word for this section is the boundary. So the boundary line is a line that breaks the coordinate plane into halves. So from these two pictures you can see here's a boundary line right here, and on this one here's a boundary line right here. And so these are inequalities, which are graphed, the graphical version of the inequality given here. And so I'm going to go to the next slide and kind of describe how to get this, and then I'll come back and look at this picture again and describe them once we've seen the definitions that they're using. So the first problem-solving tip, you're going to graph the boundary line by treating the inequality as an equation. So if you think about an inequality, it's got a symbol right here, or for example a symbol right here, but you just pretend that's an equal sign, okay, which would give you an equation of a line. So you graph the boundary line just as an equality, and you have to maybe think about, okay, how am I going to graph the equation of a line? If it's in slope-intercept form, that's great. Graph the equation by using the slope and the intercept. But you also might have it in standard form, in which case you could find the x, y intercepts. So the method by which you graph that line is totally up to you, and it doesn't really matter. You can find the slope and a point, you could find the slope and an intercept, you could find the two x-intercepts, anything you want to do. So you're going to graph this line. Now, there's two different things that could happen. One is the inequality symbol could be a less than or equal and a greater than or equal. If it's got this or equals to, then you want a solid line, and the reason that makes sense is because the equals part means that the line is part of the solution. So the solution will be the half plane plus the line included. However, if you just have a less than or a greater than but not equals to, then the line itself is not part of the answer, and to show that we use a dotted line. So to recap, if it's included in the solution, which means you have an equal sign here, you use a solid line, which is what the original solid line means, is that every point on that line is a solution. And if it's not part of the solution, we use a dotted line. Second thing is, how do you decide which half to shade? You cut the plane in half with the boundary line, and then do you shade one side or the other? So if you have your equation solved for y, so in other words, if you have it in slope-intercept form, this is the box that's going to tell you what to do. If your equation starts with y is greater than, or y is greater than or equal to, your solutions are y values which are above the line, so you shade vertically upward, larger y values. And if you have y less than or equal to, you shade below. So if you know something about the y variable, you shade vertically above or below. However, if instead your equation is solved for x, this is kind of rare but not impossible. If you know something about the x value, if the x is larger or the x is smaller, then you're looking at the x-axis, which is side to side, and you'll shade left to right. So if your x values are larger than whatever the equation is, you'll shade to the right, which is larger x values. And if your x is smaller, you'll shade to the left. So this is another possibility, but less common. And then if you don't have the equation solved for either x or y, or you want just an alternate way to do this, you can plug in a point and check it and see if it's true. Now the idea is you're shading the region where the points satisfy the inequality, which means they make it true. So if you pick any coordinate point, x1, y1, where you put in a number for x and a number for y, and you plug that xy pair into the inequality, you can figure out the value on the left and the value on the right, and then just check and see, is it actually true? If the inequality is true at that point, then that point must be on the shaded side, so you shade that side. If when you plug that point in, you get something that's false, okay, then that means that point is not part of your solution, which means the side that it's on is not part of your solution, which means you should shade the other side. So there's only two possibilities. One side is shaded, the other side is not. So just checking a single point is enough to figure out which side you should shade. And just as a comment, plugging in 0, 0 is typically the easiest thing to plug in, which makes checking really, really easy. The only time you shouldn't use 0, 0 to check is if 0, 0 is on the boundary between the two. So you have to choose a point which is clearly on one side or the other that's not on the boundary line. Okay, let's go back and look at these first two graphs and see if we can make sense of them. Y is greater than x minus 2. So the first thing we look at is the slope is positive 1 and the intercept is negative 2. So this boundary line that's plotted has an intercept of negative 2 and a slope of positive 1. Then because we have a greater than sign, but not equal to, we're going to use a dotted line. So you see it's a dotted line. And then lastly, because it's a y value which is greater than this equation, we're shading above. So we're shading everything vertically upward. So from the line, we're looking vertically upward because of this y is greater than. Now over here we have an intercept of positive 2 right there. We have a slope of positive 2, so up 2 over 1, up 2 over 1. And because here we've got less than or equal to, that or equals to means the line itself is part of our solution. So this is a solid line, which means we're including the line itself as part of our answer. And then its y is less than, so we're shading vertically downward, vertically below the line. All points below the line vertically are part of our solution. And again, you could plug in like this point 0, 0. If you plug in 0, 0 here, you get 0 is less than 0 plus 2. That is true, 0 is less than 2. So this point is part of our solution, as we can see. All right, let's just do 2 quick examples, maybe 4 quick examples. First one, graph 4x minus 5y is greater than or equal to 20. Because this one's not solved for x or y, I'm going to opt to solve for the 2 intercepts, x and y intercepts, and then plot it that way. So my x-intercept I get by setting y to 0. So if I set y equal to 0, I have 4x is greater than or equal to 20. And if I divide by 4, I get that x is greater than or equal to 5. Okay, and then to get my y-intercept, I'm going to set x to 0. So now I'll have negative 5y is greater than or equal to 20. And then I'll divide by negative 5, divide by negative 5, cancel. Y, I have to flip the sign because I divided by a negative. I have less than or equal to negative 4. Okay, I can plot this intercept. X is 5, 1, 2, 3, 4, 5. And y is less than or equal to negative 4, so I go down here, negative 4. Alright, now I'm going to draw the line. Is it solid or dotted? Well, because I have a or equal to symbol here, it's going to be a solid line. So I can draw in my solid line there. And now do I shade above or below? There's a couple different ways you could figure this out. You could plug in a point and check. If I plug in 0, 0, I get 0 minus 0 is greater than 20. That's false. So this point 0, 0 is not part. So that means this stuff up here is not the solution, which means everything down here is the solution. So my shaded region is everything down here. Another way you could see this is actually came out when I was finding the x and y intercepts. It came out to be x is greater than or equal to 5. And here's my point 5. And over this way is everything horizontally larger than 5. And likewise down here, y is less than or equal to negative 4. So from this point, less than is downward. So it just kind of all comes together to confirm our answer. So here's our final answer. Graph y is greater than 2x minus 5. So I'm going to plot this line, starting with negative 5. 1, 2, 3, 4, 5. So here's my y-intercept. Slope, positive 2. That means up 2 over 1, up 2 over 1, up 2 over 1. You can do that a couple more times. But I want to put in a dotted line because this is greater than but not equal to. And then a y is larger than, which means I'm shading vertically above the line. So I'm shading this region up here above the line. One other thing I want to comment. Sometimes when you're drawing these, you draw in a solid line, and then you realize, oh crap, I was supposed to do a dotted line. So one thing I'll allow you to do in class is to make a line dotted. You can go like this. So make little hash marks across the line, and that will symbolize a dotted line. That way if you're having trouble erasing, or you're using a pen, heaven forbid, or something like that, you can still show that it's dotted. Okay? I want to do these last 2 examples to show a special case. Sometimes you have a line that's either horizontal or vertical, and it's maybe tricky to figure out where you should use shade. So if we just have y is less than 3, at first you're like, well, uh-oh, that's just a single point, right? Y equals 3 is right here. How can I shade if I only have a single point? But remember, if I had the equation y equals 3, this is a horizontal line. And it represents all y values, not just the one on the axis. So this is a horizontal line through the y value of 3. So I'm actually drawing in a line, and here it's dotted, again because this is a less than, but not equal to. So we draw in our dotted line, and now we say, am I shading above or below? Y is less than, so I want to shade everything below. Alright, How about x is greater than or equal to negative 4? Well, on the x-axis, negative 4, 1, 2, 3, 4. Negative 4 is right here. What do you do here? If I have x equals negative 4, remember, this is a vertical line because it's representing every single possible point with an x-coordinate of negative 4. So all of these points, vertically above and vertically below, they all have that value. And in this case, I'm using a solid line because it's greater than or equal to. And things which are larger than are to the right. So I'm going to shade over here on this side to the right. So any coordinate point that you pick in this region will have an x-coordinate which is larger than or equal to negative 4. And then up here, any coordinate point you pick over here will have a y-coordinate which is less than 3. Alright, that's it for these graphs. Just remember to plot the line using your normal methods that you've learned before. Decide if it's solid or dotted based on whether your inequality includes the equals bar. And then lastly, decide which side you're going to shade on, either by looking above or below, or by plugging in a particular point and then checking to see if it works. Alright, that's it.